Hello students, today we are going to discuss about the GSM architecture in mobile computing. So what is a GSM architecture? GSM stands for Global System of Mobile Communication. It is one of the most successful digital mobile telecommunication system. It provides integration of different voices and data services and inter-networking with existing networks. So here, as we can see, the architecture consists of three broader systems, the RSS, NSS and OSS. And we can say here we are going to discuss how actually a mobile device is communicating with another mobile device. What is the backend process? What is happening behind the scene? How the call is made and what are the components that comes into play in achieving this. So here we can say the RSS stands for the radio subsystems, and the NSS stand for the network and switching substation, and the OSS stand for operational subsystems. So RSS can be considered as a front end tier, NSS as the middle end, and OSS as the back end. OSS generally consists of all the databases or all the information that we need to store in order to provide the communication, like the user list, the authentication process. And OMC is one of the important components which helps in operational and maintenance of the entire system. So here, as you can see, we have our MS. So I will go by from the front tier to the end tier, making you understand, taking you through the diagram, making you understand each and every component, what is its role, what does it do, and what importance does it carry in making this communication successful. What each component stands for and how it is being controlled in a geographical area. So we will switch to the PPT. Here I have made some notes or handouts that I'll be sharing with you. So as I said, it consists of three subsystems: the radio subsystem, the network and switching subsystem, and the operation subsystem. Now we have, forget about what's written. We will go through it again, but for your easy understanding, we will switch to the diagram again. So here what happens, the MS, the mobile system, or as you can say, whatever you're holding, the handheld devices is what a MS is. A MS generally consists of two components: the terminal, that is the device itself, and a smart card, the subscriber identity module, as we say, SIM card. The user can receive and make calls from the terminal, and through the SIM, we have the communication is maintained as per the subscription the user has opted for. BT stands for base transceiver system. Now what is base transceiver system? It handles the mobile interface and maintains the radio channels, how the communication takes place, whether it's through multiplexing, which kind of multiplexing has been used. You have been taught the different kinds of multiplexing used in order to use up the air or use up the resource. Since simultaneously all the connections can't be made on a single airspace, so we go for multiplexing. It may be space, it may be code, it may be time division multiplexing, whatever mechanism be it. So that there is an interface between MS and BTS that contains all the mechanism. The interface is called ABIS interface, UM interface. As you can see, this is our MS, This is BTS, and in between is the UM interface. The UM interface contains all the mechanism necessary for wireless transmission, and BTS are controlled and maintained by, it's very important, listen up again. BTS are controlled, maintained and coordinated by BSC. This is the component, that's BSC. Every BTS is maintained by BSC. We can think of it as a tree structure. Several BTS is controlled by one BSC. Okay, and the entire system of BSC, BTS, MS, or we can say the entire RSS system is also can be termed as a BSS, base station subsystem. Okay, base station subsystem. So what is the role of BSC again? BSC solely controls the BTS. I mean, we can compare it with the control unit in a central processing unit. As we can say, a central processing unit, a processing unit is not a simple circuit, right? It contains various other modules as well as a part of it, and which is majorly the ALU, arithmetic logical unit, and the control unit. The processing unit consists of majorly ALU and CU. CU does the part of controlling the ALU. Which circuit should be enabled at what clock cycle? Everything is decided by CU. Similarly, BSC controls this entire system. BTS. How the call is initiated, how it is routed through the BTS, through the interfaces take care of which channel should the signals be using in. And after that, as we go through this, after BSC come MSC. Similarly, as BSC is parent to BTS, if we consider it in a hierarchical manner, a tree structure, BSC can be considered as the parent of BTSs, several BTSs. Similarly, several BTS are connected to one MSC. Now, MSC controls several BSC. Now, this is not a very easy task. So, MSC has to control a larger area now. So, MSC has various databases connected with it. What does MSC has it with it? The VLR, HLR, and EIR and AUC. Now, each of these has their own functionalities. VLR is the visitor location register, HLR is the home location register, EIR is the equipment identity register, AUC is the authentication center. Now, what is an HLR? HLR actually is a database which stores permanent data about subscribers, their profile, location information, status, etc. Subscription information, what you have subscribed for, what are your plans, what is your name, where are you currently now. Everything is made available in HLR. VLR similarly stores temporary information. Suppose I am in Maharashtra now and I am moving to Karnataka. So now I am into Karnataka's communication area. So here also there will be a handover and still I will be getting services, right? My services won't be dropping. It doesn't work like that if I move to some other network location, I won't be availing Vodafone services. Of course I will be availing because of this VLR. Their communication system will provide us service, but it will treat us as a visitor. That's where roaming comes into picture. We will be on roaming. Why? Because we are a visitor to this network. Once we become as a visitor, all our information are stored in the visitor location register. It will contact with our own HLR after gaining information about us, about what is our name, what plans, what networks we are using. So it will contact with the HLR, and after getting the relevant information, it will continue to provide us with service. Authentication center is primarily concerned with protecting the data. It stores a copy of secret key that is used for channeling information in an encrypted manner, and it takes care of authorization as well. So that nobody else can be using your data, your plans. No one can be subscribed with your plan. No one. Every person with a mobile communication on a mobile terminal has its own individual identity, and that has to be maintained with some kind of protection and security which is provided by AUC. Now, equipment entity register. This is also important. Why? Because every equipment part of your mobile terminal system has to be recorded or should have one identity with itself. Suppose you lost your mobile, every valid system has to be recorded as active, and every invalid system, suppose a phone is lost, someone reported it has to be tagged from valid to invalid. That is done through EIR. There is a component called EMEI number which is used to identify each mobile system. EMEI is marked as invalid if your phone or your mobile system is stolen. It contains all the list of valid mobile network users. So I think I'm clear with each and every part. OMC is concerned with a small part. It doesn't concern us. Majorly, we will be focusing on what all we have discussed so far. OMC is concerned with operation and maintenance. We will go to the slides now. So this is what I have told you so far, which is written in a crisp and brief manner. The mobile system consists of mobile equipment terminal and a SIM card. The SIM provides personal mobility so that the user can have access to subscribed services irrespective of specific terminal. Similarly, base station subsystem. I'm just reading out for your own convenience. Now that you have understood things, it should be more easier. It should make sense when I read out these definitions. So base station subsystem is a GSM network comprises of many BSS, as I said, each controlled by a BSC, base station controller. The BSS refers to the entire system consists of BTS, BSC and MSC. The BSS performs all functions necessary to maintain radio connections to an MS, coding, decoding of voice, rate adaptation to and from the wireless network. Beside BSC, BSS contain BTS, as you know. Now, if something I have missed, no, nothing. HLR, VLR, we have discussed already. So yeah, I think that will be all about GSM architecture. If you have any doubt, post it on the NC classroom. This is Shashwati Das signing off.